So work and heat have specific sign conventions that we use in physical chemistry. I believe it's slightly different in physics if you are looking at pure physics, but we're going to stick with our sign convention here. Now, when I wrote out pressure volume work, and something that this might look like is we have some piston here where there's this is like a shaft or something. There's an external pressure pushing on this. There's gas inside, and this pushes or gets pushed on by this external pressure, right? It's working against this unbalanced force. And so we can have a volume change that happens, and that will represent work happening. Now the volume change can be plus, positive, or negative, right? And I stated that work was defined as negative P external times the change in volume. Now, why do we choose that sign convention? What does this mean? So if the change in if the volume decreases, right? So if delta V, if our piston, let me do this in a different color, moves down, that means that delta V will be negative and overall work would be positive. So what that means is positive work increases U, increases the internal energy. And that's the convention that we use. If we increase the internal energy of the system, right, if we compress the piston, it has more ability to do work because it can then push back further, right? So the more you compress, the more more energy gets stored up inside of the gas, right? The internal pressure will increase, which means it has greater ability to do work. So the sign convention is that a positive work value increases the internal energy in the system, and a negative work decreases U. And let me be specific here. We're talking about the system here. Right, so negative work decreases U system. That means the system does work on the surroundings. So to get this to work with the delta V values, you have to have a negative sign here for this convention to work out. Now we have the same convention with heat, right? So for Q, a positive Q value, or what we say positive heat, is energy going into the system. So it would have to be coming from the surroundings into the system. You may be familiar with the term endothermic when we're thinking about chemical reactions, and those have a positive Q value. The energy goes into the system. A negative Q value means heat. Negative heat value is energy leaving the system. Right? We're decreasing the total energy that's in our system. And if we're thinking about reactions, this is what we call an exothermic reaction, right? It heats up what's around it, right? We have energy leaving our chemicals that reacted, going into the surroundings, and that heats it up. So it's energy leaving the system. And so this is the sign convention we use when we see positive heat values. That means energy is going into the system. Negative heat values, energy is leaving the system. So the easiest way to remember whether something should be positive or negative is to think about what's happening to the energy of the system, of the thing that we're considering. Okay, so just as an example of what to think about, when we're thinking about, say, an electric stove, we have a coil, a hot coil here. So imagine, I should have drawn this red. Right, so we have a hot filament here. What processes in terms of work and heat are happening here? So I'd like you to pause the video and think about that. Okay, hopefully you took a second to think about that. The process of work and heat happening are we have electrical work happening. That's why the coil is getting hot. So there is a resistive, this coil resists electricity, and we pass electrons through it, and that is what heats it up. So there's electrical work happening. And then we also have the heat is the energy leaving the coil. Right, and so so that is going to go into your pot or heating in the air. So that's, for an everyday object, we can think about what are these sorts of things that are happening. So, so just to reiterate the first law, so any change in the energy of the system can only happen through these two processes. So if we have any sort of change in the system, delta U, the energy of the system, it can only occur through either heat exchange or through work being done on or by the system. That is the first law of thermodynamics, is that there's no other way to exchange energy. You can either have work that's done through an imbalance of forces, or you can have a temperature difference that is heat, and those are only two possibilities.